Hello and welcome to GM-BIST construction. Today we are going to learn how to design our roof truss. We carry out the general arrangement in our AutoCAD, and the analysis and the detailing will be done in our CIVILSOFT, also known as Quick Series Quick Structure. We'll be using the one of version 8. So the architects have actually tried to provide some details here, but as a structural engineer, we are not interested in all these details. They are just guesswork. So we have been given all we needed to carry out the analysis here. We have our ground floor, the ground floor of the church. So the width of the building is 25 meters and the length is 50.4 meters. Yes, in this church we have two sections here. This section and this down section. So our work will just cover this section from here to here. So if you have this type of structure, you are going to design the truss for this section and this one. If here is also going to be roofed, then you also design this section because there are different trusses with different lengths. So we now begin our exercise. So the first thing I do is I will just get a line here and I'll click anywhere, specify down offset. I will offset the width of the building, which is 25 meters. So offset. That being done, the next thing I will just pick my line, join it over here. So I will now offset this again. Now the width of the structure given to us, the plan here, the building is 25 meters now. There's various criteria governing the height of your truss. So you can actually check your design manual from span 6 meters to 12, the apex of 4, ratio 4 and 5, from 15 to 30, apex of 7 to 8. So there are so many criteria. So before you carry out any steel work, you must have a good knowledge of your design manual. You put it by the side because you can't do it without the design manual when it comes to steel design. So I'll be using a ratio of 4 to 5 for our span of 25 meters. Now what we are going to do is I will divide 25 by 4. So if you do that, you have about 25 divided by 9. If you do that, you have about 3 meters. It's 2.7, but when you approximate it, you have 3 meters. So I will offset 3 meters. That's the height of my truss, 3 meters. Then I will take half of 25 again, which is, if I don't know it, I can just say 25,000 divided by 2. Use offsets and you can still do your calculation over there. So you see at the center, I'll just extend it. Okay, so I'll pick my line from the intersection there to here, escape, do the same thing at the other side. Okay, that being done, I will delete this line or I will erase it. So I don't need this too. So I will try to configure my truss. So I will extend it this way, 1 meter. I take it up. This is just how I want to configure my truss. You can configure it the way you want. 1000. Enter. Take it up. Okay. will see offsets to get the thickness of my truss. Offset 1 meter again. So I'll use my chamfer it so that it meets at the center. Then I will extend it here. Next thing I do is to trim. You can actually type this command. You can use your short key. Okay. So this is how I want to configure my truss. So the next thing I will try to space them at equal distance. So I can just say from here to here is 12.5 meters. Or this is what I will do. Use my offset 12,500 divided by 12. I want to space it at 12 equal distance. So the next thing I'll do is just offsetting. So you can use your offset to do some little calculations. If you don't want to use your calculator, you do the same thing this side. Just offset. Or you can just copy at a point and paste at the other end to get the same thing. Whichever way you want to do it. Okay, we are done with the offsets. So let me change the layer. I'll change it to, let me say, red now. Okay, what I will do, I will use my polyline. I'll pick it from this end to here. Take it to this place. Okay. From here, let me off my auto mode so I can move it freely. Make sure you touch at the intersection. Do it for all. You can actually use your line command to do this using the polyline, because the system, the software, the CIVILSOFT will actually understand a line as an element. So you don't need to use your polyline, but after using our polyline we will explode it so that it becomes a single line. Okay, I've actually missed the target there. Let me undo. Yes. On reaching here, you escape, you stop. Then you continue from here. You change your direction now to here. And you continue this way. There's a pattern to which you follow. Okay. You take it down here. We'll now do for the bottom cord. At the joints, make sure you don't miss the target. Do it all for the bottom cords. Make sure you do it for all the bottom cords. And you don't miss the points. So when you come here, so stop at that place, escape, enter. We do it for the top now. Make sure you don't miss the target. Still move this way. Make sure you don't jump any intersection. So we are done now. So the next thing, you click on this, select this, make sure everything is selected, then you move, or you can copy. Yes. Now if you click on this, you discover that if I select it now, this one, this two, this three. So if you export these two, your proto structure, it will just recognize it as just 3 lines. Why that is wrong? Each of these lines is supposed to be an independent line on its own. So we now explode it. So once you explode it, you see that all the lines are individual lines now, they are standing on their own. And so this is what your software will understand, your CIVILSOFT will understand as line and as element. So it's either you use your polyline and after that you explode, or you pick your line command and you begin to move on this. You move like that. So we'll highlight this. This is just what we need. You type W, enter. So now insert units. What we used here was millimeters, so you come here, pick your, select your millimeters. It must be on millimeters, or the unit you use in designing this millimeters. If it is centimeters, if it is inches, if it is meters, you do that. So we will now save it, or let me save it on desktop. So it should always be in DXF. So the version, the AutoCAD version actually doesn't matter, but make sure your work is being saved as a DX file. So I will save it as still work. Save. So you ensure that it's only the object which you highlighted down will be saved. Don't click on entire objects or block, just the not entire drawing, just the objects. Then click OK. That's now be saved. So the next thing, we minimize our AutoCAD. I need this. So we will launch our CIVILSOFT. This is our CIVILSOFT. Double click on it. You give it some time to process. Yes, this is Quick Civil Series Quick Structure, also known as CIVILSOFT version 8. So we'll be using our version 8 to carry out our still work. So you can also contact us through the comment section if you actually need this software. It's good, very good at detailing work too. You can use it for your concrete, reinforced concrete design, and for your steel design. So you can contact us through the comment section. You can also register and be part of our classes. So we are in our Quick CIVILSOFT. Now the environment. Now the next thing we do, we go to File, click on New. Yes. No. Go to File again. Import AutoCAD DXT element. So this is what we want to import. Now the operation with import AutoCAD DXT element, before you continue, it will be important you understand how the software reads your DX file. Lines are read as T element, and that is why we needed to explode the polylines to become lines, because when you import them here, the software will actually identify them as T elements. So that is very important. Please make sure that the elements are well connected at the joints, and that is why I was telling you that you must ensure that it is well connected at the intersections of those lines. So are you sure you want to do this? Yes. So we now go to our desktop now. We save it as still work. So click OK. Yes. So this is what we have. Let's also have actually provided the grids and all of that. Okay. Let me try to adjust it. You can actually reduce the scale or increase the scale as the case may be. Let me increase it so that we see everything here. Okay. Now take this. Let's So this is what we have. Let me reduce the scale because we actually want to use it. I think this is okay. This is okay. Let me adjust it in such a way that we can be able to identify the elements. So the next thing you do is that you go to your steel structures. Under your steel structures, you click on build roof trusses. Build roof truss point load. So let me shift it this side. Let me adjust it. I actually reduce it. Reduce it to here. Okay. Then I'll click on add loaded elements. Now the first element here is what? E1. So this is E1 and E4, E8, E. Now this is arranged according to the let me see, increasing order from here: 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, like that. Now what the software actually does is that if you pick this element and this, it will take half of this, the load here, half of this, and apply at the joint here. It will load it at the joint here. So what we are going to do is that we just concentrate on this. So I will now begin to select it. Element 1. The next one is what? Element 4. The next one is what? 8. The next one is what? 12. Element 12. The next is 16. The next is 20. Next is 24. The next is 28. 28. The next is 32. Scroll down. Let's shift it. 32. The next is 36. The next is 40. The next is 44. You may select them accordingly. The next is 48. The next is 52. 56. Can we go beyond 56? We can see what is here. We just click OK. So let me try to adjust it again. So that I can see what is here. I think this is okay. I go to build my roof point. Build roof truss point load. So okay, let's shift it this way so that we'll be able to see what is here. If I click on this, I'll be able to know where I stopped. Element 52. This is where I stopped. So I'll click on add loaded elements again. I'll scroll down. 52. The next one will be 56. So the next one will be 60. The next one will be 64. The next one will be 68. The next one will be 72. The next one will be 76. You don't have to rush this process. You just take it gradual. 80. 84. 88. What is here? 92. Let's say 92. 92. 92. 96. 100. 104. And 105. So click OK. So we have selected our elements now. Now remember, I told you that when you select this and this, it will take half of the load, half of it, and apply at the joint here. So let's go back to our first element. Let's click on element 1. See element 1 here. Let's try to work on it. Can I shift it this way? Oh, factor x1 is usually 1. Now if you look at our design wind speed, design and dynamic pressure, both of them are showing 0 0. Let's try to adjust this. 75. All of this you can actually check on the design manual. You see it changing. So we can just leave this one to be at 0.75, 0.85 for the default. If you actually want to get a value, you just need to come here. Factor S value can be read off from CP3 chapter. This or other code design. This one is from your design manual. You can actually check there. Let's for our design, the basic wind speed will be 50. This is 50. The CPI angle at 90. Okay, you can see our dead load, all of that. This miscellaneous load, this one you can actually just fix it for, let me say, design factor of safety. So but for analysis we are okay with this. So the next thing for me to edit all of this individually will be a tedious work for me. So I can just select all of this, select this one, select this ones. Select all of them. Then I click here. I'll just click this one. Then I'll go to match property. This operation will make some properties of the selected loaded element the same with the checked loaded element. Are you sure you want to do this? Yes, I want to do this. So if I now click on element 2, you can see that the properties are the same. So let me just try to edit this. Take this one to 0.85. all of this you can check from your design manual. Let me edit this to 0.85. So I want to check all of this. Now check it. After matching the properties, you want to check it. And check all of them. So that being done, now the next thing you do is to build your point load. Just click on build point load. This operation will build truss point load from loaded element. Please make sure you have entered the loaded element properties correctly. Are you sure you want to do this? Yeah, these elements. Yes. Okay. You now close. So you come to point load properties. So if you click on this element 2, you can just see them being applied on the structure now. So any of them you click on it, you see the loaded elements. See then the point load 9. Let's check this. This one is 6.08. So we are done with that. If you want, you can just select all, then delete selected. But we are okay with this. So let's try to, let me go to view and try to increase our scale so that so we are here now. So you can see that at the joint here, you can see that the load has been applied. at each joint here, you can see the loads being applied at the joints. So the next thing we do is to apply our insert our support. And then insert our support now, we just click on insert support. So we insert our structure, insert point load. We insert our point load here. The first one will be pin. So this is pin. Second one. So you click on C structure, inside point load, specify. So this one is pin, this one will be roller support. So you are done with that. The next thing we do is to analyze our truss. Yes, truss analysis done. To see the element tension, or compression forces, click show results or click element property. To export details, you must click show results. To design the element, click see truss section design. So we are here now, so we'll click OK. See structure. Let's see structure, go to element property, and each of the elements I click now, this one is under compression. It's neither in compression or in tension. This one is under tension, it's in tension, compression, compression, tension, tension, compression, tension, tension, tension. So you can actually check all of them. You can check the geometry, you can check the length, of the element 9, which is this one, and it's 1028, 1.28. So you can actually check so many factors, the dead load factors, all of that. So we'll be stopping here in this tutorial class. We will continue in our design class in part 2, so stay tuned.